Hello everyone, welcome to the course Programming in PLSQL. In today's lecture, we will learn about declaring variables in PLSQL.
A variable is a named storage location that allows us to temporarily hold data during program execution. In PLSQL, every variable must be declared before it is used. When declaring a variable, we specify its name, data type, and optionally an initial value. Choosing the correct data type is very important because it defines how much memory is used and how the data is processed. Understanding variables is a fundamental step toward writing efficient and reliable PLSQL programs. Now let's move on to how variables are declared in PLSQL. Variables are defined in the declaration section of a block before the program logic begins. Here is the general syntax. First, we write the variable name, then specify its data type. Optionally, we can add keywords like constant or not null. Finally, we assign an initial value using the assignment operator. So, the variable name identifies the variable, the data type defines what kind of data it stores, and the variable value sets its starting value. This structure helps us write clear and well-organized PLSQL code. Now let's talk about data types in PLSQL. Whenever you declare a variable or a constant, you must assign it a data type. Data types define how the data is stored, what values are allowed, and what operations can be performed. In PLSQL, variables, constants, and parameters must always have a valid data type. This ensures correct memory usage and helps prevent errors in your program. As mentioned earlier, variables are declared in the declaration section of a block, and their data types are specified there as well. Understanding data types is essential for writing efficient and reliable PLSQL code. We will briefly explore data types in PLSQL and their importance in programming. PLSQL provides a wide range of data types that allow developers to store and manipulate different kinds of data efficiently. These data types are mainly divided into several categories. First, we have character data types, such as varchar, yeek, and char, which are used to store text values like names, addresses, or descriptions. Next are numeric data types, including number, which are used for calculations and storing integers or decimal values. These are essential for performing mathematical operations in programs. PLSQL also supports logical data types, such as Boolean, which help control program flow by evaluating conditions as true or false. In addition, there are date and time data types, like date and timestamp, which allow you to work with dates, times, and durations, very useful in real-world applications. Another important category is blob data types, such as blob and club, which are used to store large amounts of data like images, videos, or large text documents. Finally, PLSQL supports composite data types, including records and collections, which allow grouping multiple values into a single structure. Overall, these diverse data types provide flexibility, accuracy, and efficiency when working with data in PLSQL programs. PLSQL supports both fixed length and variable length strings. To declare a string, use the syntax declares description varchar yeek, yeekm, begin, end. This allows for efficient handling of text data within your PLSQL programs. PLSQL supports several character data types that are used to store text and binary information. Each type has its own size limits and specific use cases. First, we have char and integer data types. These are fixed-length character types, meaning they always reserve a specific amount of space. Both of them can store up to UCM bytes. Nishar is typically used for storing Unicode data, which is helpful when working with multiple languages. Next, there are varchar yeek and varchar yeek. These are variable length data types, which means they only use as much space as needed. They can store up to 2 bytes, making them more flexible and commonly used in most applications. PLSQL also includes long and long raw data types. These are designed for storing very large amounts of data, up to gigabytes. However, they are considered outdated and are generally replaced by newer log data types in modern systems. Finally, the raw data type is used to store binary data, such as images or encrypted values, and it is limited to yikmung bytes. Understanding these data types helps developers choose the most efficient way to store and manage data in PostgreSQL programs. In this PostgreSQL example, we declare variables of type varchar equal with a size of u initialized to hello world. The DIMSOutput putline function is used to display the string, resulting in the output hello world. In PostgreSQL, the char data type is fixed length. Declaring kichar allows only one character. Assigning wumber causes an error due to exceeding the buffer size. Always ensure the assigned string matches the declared length. In PostgreSQL, varchar is used for variable length strings. A buffer error occurs if the string exceeds the declared size. For example, declaring varchar for a longer string causes an error, while varchar yiru accommodates it successfully, outputting the full message. PostgreSQL supports various numeric data types, including number, integer, and binary integer. Float and decimal are alternative names for these basic types. All numeric types in PostgreSQL are fundamentally based on the number type. We will talk about the number data type in PostgreSQL. The number data type is one of the most important and flexible data types in PostgreSQL. It is used to store both integer values and floating point numbers, such as real and float. One of the key features of the number data type is that it allows you to control how numbers are stored using precision and scale. This is defined using the format number, where P stands for precision and stands for scale. Precision refers to the total number of digits that can be stored, while scale defines how many of those digits appear after the decimal point. For example, if we use number jita yika, it means the number can have up to jita digits in total, with yika digits after the decimal point. So, values like are valid, but larger numbers may not fit this format. This feature is very useful in real-world applications, especially when working with financial data, where accuracy and control over decimal values are essential. Binary integer and integer both store signed integers ranging from yika to 16 to yika to 16 in procedural language structured query language. Binary double, introduced in Oracle Database 1, represents floating point numbers in Institute of Electrical and Electronics Engineers G2's format, requiring pools bytes for storage. In this PostgreSQL example, we declare variables a and s. A is assigned bis, is initialized to nun, and s is calculated as the sum of a and p. The output is kibis, demonstrating basic arithmetic operations in PostgreSQL. In PostgreSQL, assigning a value too large for the integer data type results in an error. Here, num yiga is assigned an excessively large number, causing ora nunaltabis nunika, a numeric or value error. This highlights the importance of choosing appropriate data types for large values. In PostgreSQL, numeric data types like number, integer, real, double precision, and float are used for arithmetic operations. This script demonstrates variable assignments and calculations, showcasing how different numeric types handle division and output results using DIMSOutput putline. The date data type in PostgreSQL stores fixed-length date times, including time in seconds since midnight, with a range from January before Christ to December Anno Domini. Interval and timestamp types also store dates. The default format is set by null data format, typically standard money, showing day, abbreviated month, and year. In PostgreSQL, sysdate returns the current date and time from the operating system. The returned value is of date type, formatted according to null data format. The function requires no arguments. For example, using sysdate in a script outputs the current date and time, such as 2023 In PostgreSQL, there are three primary time data types: date, timestamp, and interval. The timestamp type extends the date type by including fractions of a second, providing more precision. For example, executing select systimestamp from dual returns a detailed timestamp with fractional seconds and time zone information. In PLSQL, timestamps can be declared with or without time zones. Use current timestamp for current time with time zone. Convert sysdate to timestamp using toDate. Retrieve fractional seconds with tocher systimestamp sysdef. PLSQL supports a true Boolean data type, storing values true, false, or null. This enhances code readability, especially in complex logical expressions. Boolean variables simplify logical calculations, making your code more intuitive and maintainable. In this example, we declare a Boolean variable, eligible for discount. It evaluates to true if the customer's balance exceeds the minimum balance, the preference type is most favored, and they are eligible for a discount. This logical expression helps streamline decision-making processes in code. In this example, we declare three Boolean variables, a, b, and variable a is set to true, to false, and k to null. The conditional statement checks a, and since it's true, the output is true. Thank you for listening. We appreciate your time and hope you found the presentation informative.